now. This slide is not updated. 16 plus. I have 17 plus now. I started my career as a Java developer. And then I've been into various shoes, multiple roles and responsibilities. I'm currently working as a principal SRE with one of the reputed giant of the world. Okay, we have huge traffic, 10K TPS traffic that we handle, multiple concurrency. We have high availability, disaster recovery setup, and all those things. So I am a consultant as a principal SRE, performance engineering and DevOps consultant, friends. On the cloud part, I have been working with, fortunate enough to work in all the major cloud, AWS, Azure, and GCP, Oracle as well for some part of my career. So that's this is the background about me. Okay, so we'll talk about this agenda and we'll start with a question. So let me start with a question. So before I start, let me understand about my audience. I would like you to introduce yourself in just few words. If you are a fresher, you can mention non-IT or a fresher. If you are from IT, just mention IT and your domain and years of experience. Let's say if you're working on a performance testing, on engineering, you can just mention PT and PE, or if you're working onto automation, you can mention automation and the years. Or if you are a DevOps engineer or a support engineer or a developer, you can please mention that. So just quickly, friends, I'm going to just take 2 minutes, use the chat option. Just help me understand so that I can relate this demo to all of you. Okay, so just help me understand IT, your core experience. Let's say you are into performance testing, engineering, right? And just years of experience, let's say 7 years. Non-IT can also mention like this, non-IT or a fresher. So help me understand about you, friends, so that we can take it forward. Okay, I do see Prithvi, performance testing, Jmeter 10 years. Okay, I see well into support domain, 13 years experience. Okay, Ganeshwar, performance tester, 1 experience. Prashant, 15 years production support and automation. Good, Prashant. Gokul, working in IT for 12 years in performance testing. Hemant, performance testing. Swapna, automation lead. Jmeter, Prashant. Yeah, Prashant, yes. You could help me understand your profile better, Prashant. It'll be better. Ravi Sankar, 17 years into test automation, performance testing, test management. Peter, software testing. Good. Welcome, everybody. Sudarshan, 5 experience to subsystem engineer, SCCM and Intune. Okay. DevOps engineer, Arlena. Okay. I hope I pronounce your name correctly. Arlene D'Souza, right? Narayan, 12 years, performance testing, performance tester, 4 years. Selva, performance testing, Himansu. Okay, perfect, good. Jakir, SRE fresher. Perfect, good, friends. Okay, I'm all set. Most of you are from performance testing and engineering background, working at the Jmeter. Few of you are working into the production support. Few are from automation. I see. Perfect, good. And I think Rahul is from functional testing. Good. Okay, friends. Sounds good. Welcome, everybody. Thank you for this quick introduction. So, friends, the question that I have is going to be applicable for all. Okay, though I have mentioned performance testing in the slide, but it's going to be applicable on anybody in IT. Okay, please answer that. Do you think everybody here in this group think that we are expected to know these, irrespective of the technology you work? Maybe as a functional automation engineer, you may not understand or you may not say yes to this question because you are basically talking about the application performance. Okay. Anybody, any question? Okay. Anybody wanted to say something? Okay. So here is the question, friend. Do we all think that we need to know these technologies, these skills? We should have these skills as of now in the market. as a performance tester, engineer, as an SRE, as a production support, system admin, Linux admin? Do we think so that we need to know all of this? DevOps, microservices, containers, and cloud, right? So this is a simple question I'm asking. So I'm getting responses. Prithvi says 100%. Ganeshwar says yes. Ravi Shankar says yes, definitely. Peter says yes. Swapna says yes. And I believe few of you would be nodding your head yes, right? Absolutely yes, friend. Why we are talking about why I have put these things only in the first slide, right? Why I have put this in the first slide? The answer to this lies in the next slide. Because when we understand how the software has been developed and deployed over the years, the IT industry started in 1980s, late 1970s, early 1980s. Since then, we have come across approximately 45 years since IT was from its inception. I'm talking about since its inception. And why I have put these four things? Because this is what relevant in the current market. You will understand when you see my next slide here. Look at this. So this has been our journey over the years. If we talk about the development process, when we started our IT, so the first line talks about the 1980s to 1990 transition. When we started our development process, we were from the SDLC process, software development life cycle, the how we went about, how we go about developing a software. That's what we call it SDLC. I hope um, everybody understands this, right? Software development life cycle. Do we all understand this, friends? How we go about developing a software. Every software starts with a problem statement, be it Make My Trip or your Swiggy that you see, or you see your Blinkit, right? Or you see your any application that you see, Facebook. Every software that we see is starts with a problem statement. Somebody wanted to solve a problem. And then we went about discussing its architecture, writing code, we do testing, we deploy the code to production. That's what we call it SDLC. How we go about developing a software. If I talk about SDLC, when we started our journey in IT, it was all about waterfall. We were using monolithic applications. Nowadays, we have microservices. And from waterfall, we have transition to DevOps, Agile, and then DevOps. We need to understand this. This transition has been of 40, 45 years. Nowadays, everybody talks about DevOps. Why? Okay, we need to understand why. That's what we're going to understand this in this slide. And then we all started with monolithic applications, big everything put together, monolithic. Nowadays, we're talking about microservices. Why? Why microservices? Why not monolithic? What is the problem with monolithic applications architecture? Why we are talking about microservices? The way we go about deploying the software, we need to deploy somewhere, right? We need to deploy somewhere. The code that we are writing, we need to deploy somewhere. Earlier, we were deploying in a big physical server. There was no concept of virtualization and there's no concept of containerization, no concept as such. We simply took one big server and deployed the whatever application we deployed, tiny little application, few KBs, MBs application that time, whatever we had, we deployed on a big physical server. We're wasting a lot of resources. Then virtualization came and then containerization came. We're talking about containers nowadays. Why this transition? And then again, we need infrastructure, right? So if you have a business idea back then, there was no other scope. You have to set up your own data center, like how Amazon did it, how Google did it, how Oracle did it, HP did it, IBM did it. They have to set up their own data center, which is a very costly affair. But nowadays, friends, if you have a business idea, You don't need to set up a data center. We can get some server storage. We can use cloud services, deploy our application. We can be up and running in. Hardware is not a problem nowadays. We can pay on a monthly basis. That's the cloud for you. So this is the current trend we are right now. Maybe after 10 years, you may see a different one more entry here in this list. But right now, this is the setup. And that is why irrespective of the technology, irrespective of the skill, the team that you are, everybody has to be comfortable with these things. It is absolutely must. Only I would say the functional testing team or automation team, they are talking about functionality of the application, right? They are, or the security team to some extent, they need to understand all of this. But from the testing perspective, only those people, those group, they do not care about the underlying infrastructure. They only care about the whether the application is performing as expected or not. Except those, everybody should be aware of this thing. Think about as a performance tester. We all are here. Most of you introduced that we all are performance tested. When we test, if we don't know whether it's a monolithic applications, how it has been designed, how we have given the infrastructure, how can we recommend things? We cannot recommend things, right? We need to know how the what is the infrastructure? Is it a VM infrastructure or it's a container? How the software has been deployed? If we don't know the cloud environment where we set up all the infrastructure, all the services, server, storage, load balancer, auto scaling group, everything. Ravi, your camera is live. Yeah, better you can switch off your camera, Ravi. Good, thank you. So we need to know, friends, when the services are deployed in cloud, we need to know how it is being configured. Because for a performance team, for the SRE team, for the DevOps team, it's must. We have to know how the software has been configured. What is the configuration we have done? And if we, let's say somebody doesn't know cloud, when we don't know how it is configured, then what, as a performance tester, when you test, when you load test, what are you going to recommend? Because as a performance test team, we need to recommend, right? We need this infra is good enough. We need to understand all the production load, how the software has been. We need to understand a lot of things about the technology architecture. I'll keep it simple. So we need to know this, right? So let's start this. So friends, I hope you got the context that why we are talking about these four things: DevOps, microservices, containers, and cloud. I hope we are all on the same page. Let's understand this one by one, each one of this. I need a thumbs up from all of you if we all are on the same page. Shall we talk about this slide more? Yes, everybody on the same page? Good. Good, friends. Let's talk about this. See, what is waterfall? Let's talk about this development process. Waterfall. See, the way we went about developing the software, what we did, what is waterfall? We developed everything once. Let me just use a paint, friends, just to make things simple and to make you understand about waterfall. So an application has many modules. I'm calling that the complete application as this is my application. And I may have multiple modules here. Module 1, module 2, let's call it module 1. This is M1, this is M2, right? This is M3. I'm just calling it different modules, M4, M5, M6. A lot of features put together. I'm calling it as the application. 20 such modules make your application. Now in waterfall, what we did, we developed everything at once. Whatever we decided, everything we developed. And when everything was developed, what we did, we started to test the application. We started a testing process. when everything was developed, when the code was completely ready for all the modules, it took years, 2 years to write the code. We keep on writing the code because we started, right? That's how we started. We wrote the complete code and then we started to test. Do we see problem with this approach, friends? We did not test in between. We did not test in between how things are going. We did not do functional testing. We did not do performance testing. We did not do any testing in between for any of the modules. We just took here 2 years to write the code and then we started to test. Do we see a problem with this approach, friends? Feel free to unmute yourself and let's have this conversation.
Raushan, yes.
Go ahead. What do you see, Narayan? What is the problem?
So, for example, if there is any bug in the application, we can't move to the previous phase.
Okay.
Okay.
Who is speaking,
Yeah.
Narayan or Nageshwar?
Gnanish.
What is the
Narayan
name?
here. Yeah,
Okay,
sorry,
Narayan,
sorry.
you are
Please
Narayan.
continue,
Okay.
continue here. No,
Yeah.
Okay. Okay. Please go ahead.
no.
Okay.
This
Yes.
is. Let me. This agile methodology. It will take time. So it will take a long time to deploy, to develop and deploy for the testing purpose. So
It's
whereas,
waterfall. Okay. It's waterfall. So let me correct you. We are talking about waterfall approach. Agile will come later. Okay. It's a
okay,
waterfall approach.
yeah.
So
Sorry,
this is the
it's what.
waterfall. We developed everything once and then we started to test. So as everybody would have guessed, we don't want to get surprised. Mostly we got surprised at the end. Okay, that is what happened. Eventually we got to know the application is not scalable. Let's say the application is not able to scale more than 10 users. What will you do now? After doing all the development work, you are finding out the architecture has a flaws. Now, can you go back and re-architect because the entire code you have written on that architecture? Is it easy to make such changes?
No.
No. Right? Fundamental flaws finding so late is not good. That was the problem. See, we learned from our mistakes. A lot of this is a primary thing. Okay. So we went to agile now. And what we did in agile, that next process that we have is agile. What we did, the same development, what we did, we took in phases. Okay, I will develop phase one first. We'll take this functionality. These four functionality will take up. Then we will develop it, test it, functional test, automation test, performance test, security test, everything we will do, UAT testing, every testing we will do. And then we'll go back to the customer for the feedback. We'll take the feedback, we'll show some prototype, and we'll get the feedback from the customer. And the same process will go on in the next phase. Phase P2, again we'll take some storage, right? We'll develop some code, we'll test, we'll do functional testing, performance testing, security testing, UAT testing. We'll do all those things. Again, we'll take the feedback to the customer. And this is how we went. Makes perfectly sense. That's how we do things. That's how these things should have been. So that's the agile for you, friends. I hope most of you are in agile here. How many of you are working in agile here, friends? Most of you. Yes. Quick thumbs up.
Yes.
Yes. Narayan is working on agile. How about others? Use the chat option, friends, or you can use anything. Okay. Yes. Good. Now, what is the why then DevOps? See, there is no problem with agile as such. Only the manual part. Okay. Only the manual activities, which took a long time. What is the manual type? So when the code is ready, think about it. When the code is ready, friend, what do we want what do we want to do with that code? When the code is ready, when the developer is ready with the code, what do we want to do with that code? Anybody? Simple answer it is, okay? Not complicating at all. Simple question, simple answer. What do we want to do with that code?
We have to deploy
Deploy.
in.
We want to deploy the code to production. Simple as that, right? But we cannot simply deploy the code to production. We have to deploy in some lower environment. We need to do functional testing. One functional testing is done, we will do performance testing. Now, functional testing could be done manual or automation. That's different story. Functional testing, then performance testing, then security testing, then UAT testing. Now, all these validations, when all these validations are done manually, think about it. Do you think it's going to take a lot of time for you to deploy the code to production? Yes or no?
Yes.
I'm going to just show you one slide, friends. Okay, just simple slide. Look at this here. All these are steps. I'm talking about all these steps. How we go about developing a software, SDLC. And let's take this example of Make My Trip, right? We have all these steps. When the developer is ready with the code, writing the code, we want to deploy the code to production, but we have a lot of validation steps in between. We don't want to skip all the validations. We need to deploy in some lower environment, do the testing, various kinds of testing. And once we get a green signal, when every team signs off, we only deploy the code to production. Now think about it. When these things are done manually, do you think the agile process becomes slow? Functional team will raise a bug. Developers will look into it. They will fix it. Now once they will complete, it will code will come to performance team. Performance team will test, will raise some bugs. We'll again discuss with the developers, security team. These things delay the process. And that is what DevOps talks about. DevOps is nothing different than Agile. Okay, there's no problem with Agile process as such, the way we go about developing the software in phases. The only problem, the only thing what DevOps talks about is increase the release velocity through automation. When the code is ready, we don't want to wait a long time for the code to go to production. It doesn't mean we'll skip these steps. No, we will automate everything as a pipeline, CI/CD pipeline, continuous integration and continuous deployment. We will automate the entire process. What is the process? What are different steps we are talking about? We're talking about here building the code. Let's say if the code has been written in Java, we need to build the code. We need to compile the code. We need to uh, do the unit testing of the code. Then we package the code. It could be .jar file, could be a war file. We need to package the code. Now, when we package the code, we need to deploy some to lower environment. So these are all these steps. And if we could automate all these steps, we could fast track the process. And that's what DevOps talks about. Friends, are we on the same page? What DevOps talks about, what DevOps solves. So Agile plus automation, you can take as DevOps. DevOps talks about the better collaboration. If you look at the DevOps word, friends, it's combined of two words, development, DEV, development, and OPS, operations. So it talks about the better collaboration between the development team and operations team. If you are not a developer, you are into operations. So in this group right now, we all are operations. We all belong to operations here in this group because we all are testers. We all are production support. We all are operations. So once we get better collaboration with the development team, and that is what it will help the company. We can go fast. When the code is ready, we can easily validate it, quickly validate it, and deploy the code to production. And that's what DevOps talks about. Friends, are we good with this development process, SDLC models?
Yes.
Good. And that's what we talk about, right? So this is why, and we need to learn a lot of things, tools. How could we automate? So we need to learn tools, friends, because the automation that we talk about in DevOps is at the organization level. Every team has to contribute. A DevOps engineer cannot just work on, it cannot work separately in silo and make this work. No, DevOps engineer has to work with the development team, has to work with the testing team, has to work with the performance team, has to work with the security team so that they can automate the process. Performance testing team has to help with some performance job. It could be Jmeter, LoadRunner. We need to write some Jenkins job. Jenkins is one of the tool which can help automate which can help CI/CD pipeline creation. We have Argo CD for the continuous deployment. We have Jenkins for CI. So a lot of such things is there. We will talk about in the course what do we have in the DevOps. So DevOps engineer has to work with all the team members because it's the organization level goal. So don't think, oh, I am performance team. Why I need to worry about the pipeline? No, because your one of the validations are important. Performance team validation is important. One of the approval has to be there from your team also as a performance team member. When you don't approve the code for the performance, the code will not go to production. Right, your approval is required, and then you need to contribute to the automation, the CI/CD pipeline. You need to be a part of the pipeline. So we need to talk about how a performance team or automation team can create a job, can help create a job for the DevOps team for the CI/CD pipeline creation. That is at the organization level goal. Right. Now, coming to the second part, friends, application architecture. When it's all started, we were writing everything in a monolithic way. What is monolithic? Again, I'll show you a diagram that will make things easy for me. I'll just do one thing. Let me just give me 30 seconds. Okay, friends. So what is monolithic and what is microservices? The understanding has to be important. Everything is mentioned here. So what I'm showing you here, friends, is the 3-tier architecture. I'm showing you that a web server which renders the web pages. When you hit flipkart.com, the page that you see nothing but the web server, then the logic, what the web page does actually, that the application server, and then obviously all the details are in the database. Either your product details or user details, you complete the order, every detail has to go to the database eventually. Right. So this is the 3-tier architecture is simply I'm showing you. So focus on the application server where you have the application logic, the code that we write for any application. We have modules. We have different modules, functionality, M1, M2, M3, M4. The modules which I was talking about some time back, friends, this is the module M1, M2, M3, M4 is what I'm trying to show you here. Each module has functions. We write the code. It could be we could write the code in Java, Python, Node.js, Go language, any language. We need to write the functions. Let's say M1 has 20 functions, M2 has 30 functions, M3 has some function, M4 has some functions. What is monolithic? When you package the entire code together, that is monolithic packaging. What does it mean by packaging? I'm calling, so there is a huge dependency. When I'm writing F1, I'm calling other modules, like how we import. If we have written a code, friend, we write import this package. Then we create object and then use the functions available in that package. So that's what I'm talking about. I'm talking about dependency here. In monolithic application, there is a huge dependency of functions of each other modules. If I'm writing function in M1, I'm calling other modules, functions from other modules. If I'm writing M2, I'm calling functions from other modules. There's a huge dependency across the modules of the functions. And we package it together. We get one jar file, one var file, one ER file together. Huge dependency. That is nothing but the monolithic applications. We have been doing this from very long time. There are many companies who are still into monolithic and they're trying to change to microservices. We'll talk about what is microservices. But when you package everything together, when the huge dependency, the functions are being called anywhere and everywhere across the modules, that is nothing but a monolithic applications. What is the problem? Can anybody highlight some problem? Few problems or few merits, whatever you think like. Just I want to understand your opinion, friends. What do you think of such applications? Anybody?
High
Quickly
usage
for
of resources.
high usage of resources. Okay. You mean that even if one module doesn't require more resources, there is no scope. We have to, even let's say one of the modules, one of the few endpoints take more resources. I mean, irrespective of that, we need to scale it up for the entire code, right? Is-
Yeah.
Okay, okay. Yes, absolutely, yes. Fault in one module will impact other. Absolutely, Gokul. Absolutely. Friend, because of dependency, the issue with one of the function, let's say F1, issue with one of the function, let's say if F1 is not working, it has a potential that it could bring the entire application down because huge dependency is there. If F1 is not working, M1 will not compile correctly. And F1 is being called, M1 is being called in various other modules also. So the issue with one function can bring the entire application down. You cannot do frequent deployments. You have to wait for quarterly release. Your deployment will go slow. The changes will not go to production to your customers so easily. You will be scared making one change. Every team, every code would be compiled again. Right? Lot of problems. Now, again, one of the problems I would say, let's say you started writing your M1 in, let's say Java or Python. Let's say Java. Java is still the most popular language, friend, Spring Boot. Let's say you started writing the code in M1 in Java. You don't have any other option for other modules, future modules. Let's say you are developing your business, you're growing your business, you need to add some more features. You don't have any other option but to select Java for your future modules. You have to stick to the same technology. If you have been writing in C, you have to write the same. If you have selected Ruby in the beginning, you have to continue with Ruby on Rails. You cannot choose a best technology at one point of time in future because you're calling the function directly. How can you call the function two functions written into different language? Doesn't matter. It doesn't work like that. So what is the solution? Split it. And that is what we call it microservices. When you split this monolithic applications, the end result that you get is nothing but the microservices. Independent, self-sufficient applications is what called microservices. I'm going to split the code M1 separately, M2 separately, M3 separately, M4 separately. I'm not going to call the functions. If M1 needs some information from M2 or M3, M4, they will call the APIs. I will expose APIs for each modules, for each microservices. We'll expose API, get call, post call. We'll expose APIs. If M3 needs some information from M1, yeah, they will call the API and get things done. Now I can write M1 in Java, M3 in Go, M2 in Python, M4 in Node.js. Doesn't matter now because I'm not calling the functions. I'm exposing the endpoint. Endpoint can be called even if they are written in different language. For example, friends, when you go to make my trip, I have given this example here. When you go to make my trip, when you search source, destination, date, when you click on search, it makes a call to all the flight carriers and it displays every flight carrier details of that particular day. Do you think Make My Trip owns the database of each flight carrier? What do you guys think? I would like to understand from you.
Yes.
Do you think Make My Trip owns it? Yes or no?
No.
It will call the APS, endpoint APS. Yeah.
Correct. Correct. Make My Trip doesn't own anything. You can go to Indigo, purchase. If you want to use Indigo API, Indigo has exposed APIs. Clear Trip, Make My Trip, or so other website, they have purchased API from Indigo. They pay some amount to Indigo. Indigo has been written in different language, Make My written in different language. They have exposed endpoints. Even anybody can go and purchase, use those endpoints and get the details. They call through API. If you are trying to get some information, call the get API. Get the API, and what Make My Trip does, it says show the details in a good format for you to read, for us to read. That's what Make My Trip does. Just a mediator between you and other websites. So but it gives you the unified platform, unified view. That is why we use Make My Trip or Clear Trip. You can, no, if not, you can go to individual website also, you can book the tickets. We call the APIs, friend. Make My Trip doesn't own anything. Now, when you try to book the ticket, you do a post call. You provide all the details, passenger name and every details, and then you post the code, and then reservation happens, order happens, booking happens. Everything is through API. So that is what the microservice we're talking about. So we don't call the functions, we'll make it independent. When we use, let's say we are in Swiggy, we are using, right, Swiggy, Jmeter, we are using so many websites. The payment gateway is a third party. Right? We go somewhere, now it's UPI. It is calling UPI. Our request comes to our Google Pay. We can just say yes, and we make the PIN code, and the payment happens through a third party. All these through API communication is happening everywhere. API. The payment that we do with API. Anybody can integrate the payment API things with any application. Third party. So that's how it works. So friends, are we clear on the monolithic versus microservices? So microservices, why we do it, makes, look at from the application perspective, it makes the application more available, more reliable. Issue with M1 is not going to impact other modules. If issue is there with Indigo, do you think Make My Trip will get impacted? No.
No.
Two different applications, same thing, right? M1 is having some issue. It's not going to impact M2 core functionality, M3 core functionality, M4 core functionality. It's not going to hamper that. So we need to only fix M1. To fix M1, you don't need to deploy other modules code. So these modules are nothing but the microservices. Making sense, friends? Monolithic versus microservices. Are we on the same page?
Yes. Yes, sure.
Now, the bigger question, where do we deploy this? Yes, Subham, you have a question? Go ahead.
No, Raushan, I'm okay. I'm all good.
Okay, you have raised the hand. Okay. Raising the hand means you have a question. Okay, no problem. So now the next question is, where should we deploy this monolithic application, the big code that we have? And then we have microservices. Where do we deploy this? So friend, this has always been a challenge, and we have progressed a lot in this space. The way the infrastructure, we are using infrastructure is, we have optimized a lot. We have made huge progress. So when it all started, friends, we were deploying things on physical server. We were deploying things on physical server. Okay, let me just again show you one diagram. We were deploying things on physical server, friends. This physical server. So think like your physical server is having good amount of resource, let's say 50 core, 200 GB RAM, and you are deploying some tiny little application, few KBs or MBs application you are deploying. Do we see a problem with this, friends? Anybody see a problem with this? What is the problem?
Wastage of resources if the application is just
absolutely
MB.
Yes. We are using full physical server. Unnecessary. We are not utilizing the resources better. And trust me, even if in today, if the bill is 10,000 per month for any customer, 90% of the cost, 90% of the cost goes in the server. We have been doing so it was so around 1980s, friends. So this has always been a challenge and we have made a good progress. I'll talk about that. So we are wasting resources. Then around 2000, a technology came, virtualization. Virtualization. What did we do? We installed a software on this physical server called virtualization software. We installed a software. You can virtualize your own laptop also, by the way. You can use the virtualization software. Let's say your laptop has, let's say, 16 GB RAM and good processor. Let's say 16 core processor. You can create 4 VMs, 4 virtual machines in your own laptop also. Using a virtualization software, you can virtualize your own laptop as well. You can create 4 different VMs, virtual machines inside your laptop. So this is the same technology I'm talking about. So we installed a software on this physical server called virtualization software like Hypervisor or VMware or Oracle VirtualBox or Hyper-V. Hyper-V is from Microsoft, VirtualBox is from Oracle, VMware from VMware. And we can install this kind of software and we could create VMs. VM1, VM2, VM3. We could create multiple VMs. And now in each VM, we can deploy the monolithic applications. Like n-tier application. In VM1, we can deploy web server. In VM2, we can deploy app server. For VM3, we can deploy database server. We can do that. So yes, we progressed a lot. It was a great thing back then. Still, we're using VMs. VM offers security, virtualization. You can trust this in productions. We have been using this VM for many years. And we could utilize the resources better. So all good. OK, we all did good in virtualization. We could create VMs and we could deploy applications. Now, around 8 years back, around 2015, 8 to 9 years back, 2015, there came a technology again. Because controlling VM cost for any organization has been a challenge. Look at this. So because I have been into FinOps domain, FinOps means nothing but the cost optimization domain. And you get, as a performance test engineer, you can run the load and you can size your infrastructure better. If you do that, you can optimize a lot of cost. Ravi, we'll talk about security. We'll talk about the agenda right now. We are talking about virtualization and resource optimization. There are a lot of ways security can be done. OK. So think about it. So we could deploy virtualization software and we could create VMs, VM1, VM2, VM3. So over the years, we found that we are not able to utilize the VM resources also completely. The VMs are mostly to 20 to 40% utilized. Yeah, it's much better than directly deploying on the physical server. Much better. But eventually we are 20 to 40% utilized. 20 to 40% utilized. So around 8 years back, there came a technology, friends, called containerization. And what did we do? In one VM itself, I'm showing you one VM, OK? This is one VM. In one VM itself, we can create multiple containers and we can deploy multiple applications. We can create multiple containers, and in that we can deploy multiple applications till its full capacity. So if you were using 3 VMs for app server, web server, database server for 3 VMs, now in one VM itself, we can create 3 containers. one for the web server, web container, another app container, another database container. We can create 3 containers. And if that after that, if you require more containers because you have more traffic, you can use the next VM. So with that, we found that we could optimize the cost by 50 to 60%. Right? 50 to 60%. Okay, so Ravi has a question. Ravi is asking, so Ravi, the major advantage of using virtualization, of using VM is on the cost part, first of all. Cost part, first of all. And there is no problem with the VM. We can do a better firewall. Now for VM1, we can have a different firewall setting. Let's say if it's a web server, we can have a different firewall settings for web server, different firewall for app server, different firewall for database server. We can have, if you're deploying multiple applications in the same physical server by using the same hardware in 3 VMs, we can have different firewall for each of my applications. Okay, just to give you context. Now, coming back to the topic, containerization, friends. So in one VM itself, we can create 3 containers. One container will have app server, another will have database server, and other will have web server. What is the main advantage? How could we do that? We need to install a software called Container Engine. We need to install a software called Container Engine on the VM. Every VM has the OS. On top of that, we will install a software called Container Engine. Like how we install a software called virtualization software on the physical server, we will install a container engine like Docker or Rocket. These are the examples of container engine. We'll install container engine on the VM, and then we can create multiple containers. And what we will deploy on the containers? The applications, the microservice application, any application you can deploy. What is the main advantage? Our end goal is only one. What is the end goal? Efficient utilization of the resources. We don't want any underutilization. We don't want resource to get wasted. And the containerization helped in that immensely. It helped in such a way that overall the company has reported when they switched from VMs to containers, the same application, whatever they had in VMs, deployed in VMs, when they use containers, when they use just the containers, same applications, they could optimize the cost by 50 to 60% up to. Because you're utilizing the resources better. You don't have underutilization, you don't have wastage. And that is the main intention of this. Okay. Sounds good, everybody? What is the container? Yeah, we'll talk in detail. So container like a mini process. Think like a process. Like how we have process, like this is my laptop right now. I am running Teams application. I'm running Chrome application. I'm using Paint. They are my process. So containers are like processes for the VM, but they're very unique. We will talk in detail. We have a topic, good topic in the course. We'll talk about that. Correct. Containers are in VM, Gokul. Yes, that is what. So we took one VM. That's what I'm showing you. Everybody, don't get confused. We took one VM. We containerized that VM. We could create multiple containers in that VM and deploy applications in that. Why? Because we wanted to utilize the resources better. And how we do that, we'll talk about it. We have in detail things about the course, but that's how the technology I'm talking about. Friends, are we on the same page on the physical servers, virtual servers, and containers? Getting comfortable with this slide? The last, but never the least, where is the VM? VM is in the cloud. Earlier, when things started, you didn't have any option. You have to set up a data center, friends. There were no other option. I'm going to just again show you a diagram, friends, of the data center. So let me just take you to one of the entire the document that I share with the course. I'll talk about the course. I'm going to open one of the PPTs on the cloud that we have, and I'll just show you what do you mean by a data center. So consider this facility. Consider multiple acres of land, this kind of facility in the outskirt of a city. This facility, that's what you call it data centers. And in this facility is full of the servers. That's called a data center. So so now we should talk about what is on-prem and what is cloud. That's very important question. When you own this facility, if Amazon.com has this facility, data center, Google has such facility, Oracle, IBM, they have such facility, they can call it on-prem because it's their facility. They have purchased the land, they have constructed the building, they have purchased all the servers, they have done the cooling mechanism because this servers will generate a lot of heat. They have multiple redundant power sources, multiple redundant internet. They have people employed for the security and lot of things. It's a very costly affair. When you own such facility, you can call it on-prem. But when somebody else owns it, let's say AWS, Azure, when somebody else, when they own it, we call it cloud. That's the only difference. It's all about who owns the infrastructure, who owns the data center. So earlier, there were no other option, friends. We have to create our own data center. If you have a business idea, please create your own data center and get things deployed. But nowadays, we have a lot of such data centers available. People have invested a lot and they have a business model. AWS, Azure, GCP, they have this business model. Like how we have business model, right? If some builder, I can own 100 flats, let's say, and I'll put on rent. My tenant that is not going to own the flat, but they're going to pay me the rent. That's the cloud business. They have invested a lot in the data centers. Now, right now, I don't have that much capital to set up my own data centers, but I can pay monthly bill. I'll use cloud services. I'll use server storage. In the entire Netflix, they use AWS. All the content that you watch in Netflix, they're in AWS, friends. They use storage service. S3, they use one of the storage services. So I can use server storage. I'll pay them rent. I don't own anything. The moment I stop paying the bill, my service will be non-operational. The same thing. If my tenant doesn't pay me the rent, the tenant is not allowed, right, to stay. That's simple. That's the cloud business. So that's how we have been transitioning, friends. So we need to know the cloud, how we deploy things. So every cloud, friend, has this management console. I'm showing you about AWS. Every cloud has this management console. We need to learn things. How do we create server? How do we create storage? How do we create load balancer? How do we create auto scaling group? How do we create containers? What are the different services we have? How do we do security? In security, we have so many services, web application firewall, seal for DDoS attack, right? So many things that we need to learn in the cloud when we want to use it. They have many services. They have made our life simple. How they have made our life simple. We need to understand, learn about cloud. Then only we would be able to understand this. Same thing, same admin console you have for Azure and for GCP also. The use case remains the same. Everybody offers the same thing. Whether you rent it from one builder or another builder, the flat is going to be the same. Only the look and feel will be the dimension will be different. Same thing happens in the cloud. Whether you go to AWS or Azure or GCP, you get the server, you get the storage. Only the look and feel and the way you provision will be different. but eventually all are the same product. So if you know one cloud, it's easy to learn others. Okay, friends, are we good with this slide, everybody? Everybody, did we learn all something today?
Yes, Roshan.
Yes.
Yes, sir. Yeah.
Perfect, good. Okay, so I'm going to talk about the course, friends. What is the course that I'm coming up with and how it's going to help you in your career? Because I have been in your shoes and that's why we have customized this course as per the requirement market trends. So I'll talk about the course now and what all we're covering, how we're covering, what all we're going to documents, everything that we are going to share. I'll talk about that in the next 30 minutes. Yeah, Prashant. So your question, I'm going to answer the question in the next module. Yeah, Prashant, you have raised your hand. Any questions you have? Prashant, I see your question. You have raised your hand. Do you have any question? I'm going to answer your question in the next 30 minutes. You're gonna understand. I'm going to explain your question in detail. Okay. Please lower your hand, Prashant. I get confused whenever somebody raises the hand. Means they're asking question. Okay, good. Friends, the course. Okay, can you come again?
Question. This is Selva from Chennai.
Okay.
It's a
Okay,
100%.
Selva, go ahead.
Is a 100% theoretical class or is a
No,
practical class?
nothing theoretical. Nothing theoretical. Nothing theoretical. So give me 30 minutes to explain about the course. I have not started to talk about the course at all. Let me start. Give me time, 20-30 minutes. You'll understand everything about the course. Sounds good, everybody?
Yeah.
Okay, friends. So the course that I have is called Cloud Performance Engineering in DevOps. Okay, and SRE. Okay, let me just. This is the big thing with the teams that I have to always do this. Okay, they take the first. Okay, so friends, this is the course. I request everybody to be on mute. If you have any questions, feel free to ask the question. Okay, so friends, this is the course, one course that I have. We call it Cloud Performance Engineering and DevOps. And the other course that we have, we call it SRE. Okay, so there are common things and there are some separate things as well. We'll talk about this. Then you can decide what do we have. I'm going to talk about SRE. Okay, this course, I'm going to talk about this. It's very much similar to Cloud Performance Engineering and DevOps. The additional thing, I'm going to talk about this. Yes, let me share the link first of all. Here is the link, Ravi. Please bookmark this link. I'll be also sharing this link in WhatsApp, but please bookmark this link right now. I'm going to talk about in detail. So friends, as we discussed about the 4 topics, our course revolves around that. And everything is hands-on. Okay, everything is hands-on. There is nothing, obviously, if you want to learn something, I need to explain something, but I will demonstrate everything in the cloud. So our course revolves around these topics, cloud. And we are from the cloud, we're talking about AWS, Amazon Web Services. And this course is from scratch. I have a confidence that even I can teach a 12th standard person. Okay, it doesn't matter. But if you have a IT background, it's going to immensely help you. When I say IP address, when I say port, you should be, if you understand the basic things, you're all good. Okay. So on cloud part, this course talks about the AWS in detail. What are we going to cover in cloud? We are going to cover these many things from scratch. What is cloud? How different it is from on-prem? What are different service models that we have? Infrastructure as a service, platform as a service, software as a service. How do you do budget setup? How do you create AWS account? How do you make sure that you don't pay any amount while learning, while doing hands-on? Then use cases, the servers. How do you create servers? How do you create storage? How do you make sure security is there, right? How do you create load balancer? Auto scaling group, very important from a reliability and performance engineering perspective. Auto scaling, because throughout the day, the load is not uniform. And unlike on-prem, you have not purchased the servers. So if you can use less when there's less traffic, you're going to optimize the cost. So auto scaling group is very important. How do you auto scale servers based on conditions? How networking works? How databases works in cloud? So everything is hands-on, friends. Everything is hands-on, and every system will be recorded. You can check my review in the website. All I can connect to many folks. So all those. So everything is hands-on, friend, and everything's from scratch. Everything is hands-on, and I'm going to demonstrate everything in the cloud on the day one itself. I'll be telling you how do we create this account, and everything will be discussed. So when I say about the server, we have service. Everything is through services. We will use EC2 to demonstrate how do we create servers, and everything topic is around reliability and about performance. So for me, the reliability and performance is the utmost criteria importance. High availability, reliability, and performance. Cost. I always talk any service in this language. How can you make it reliable? How can you make it performing well? How can you optimize the cost? How can you achieve high availability? Because that is very important from the performance perspective and from the SRE perspective, the reliability perspective. So we always talk about every service in this four context. So it's not going to be just talking about the service. No, it's going to be talking about four things. How do we achieve reliability, high availability, performance, and cost optimization? Every service that you see here will be discussed in those four things and from scratch. So you have, friends, every topic that we are going to cover is here. I'm not going to do in detail. You'll get bored if you have never heard about these services. So I'll just stop it here. That's what we're going to talk about in the cloud perspective. Now, moving on, I have realized that people over the years, I have realized that people, candidates, those who join my course are not comfortable with Linux. In general, also, they are comfortable in Windows, but they are not comfortable in Linux, which is not good. So I have a separate module, friends, where we talk about basics of Linux. Basics of Linux. Because Linux is just an operating system, and you should treat like one. Don't think what is that? I need to put commands for everything. In Windows, everything is UI based. I just click next, 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 and things gets done. Similar thing happens. You just need to know how things work in Linux. And it's the prerequisite session. So I have taken sessions here, 4 hours of sessions, everybody, and I'm going to share the recorded session. Okay, so this course is a very vast course. So what we have done, we have split into recorded session and live sessions. The live sessions, we go for 3 months. We meet every weekends, 2 hours each, Saturday 2 hours, Sunday 2 hours, 7:30 p.m. IST to 9:30 p.m. IST, Saturday and Sunday. We meet for 4 hours every week, and we go for 3 months. So you can consider we have 40 to 50 hours of live sessions. And I don't want you to miss on things. So we have recorded, it's going to be fine, my recording. I have recorded the session so that you get these basic things, cloud part. So not the cloud part is complete live session, the Linux part, and a few other things. I'll talk about this. So Linux part, it's going to be my recorded session. So I'm going to show you the recordings, friends. Let me show you the recordings that I'm going to share. This is the recording I'm going to share. Okay, so let me talk about this first. So this is the one of the batches. When the recorded sessions, the live sessions, the recordings, right now we are recording. So this is going to be one of your demo sessions. Like this, you will be creating a playlist. I can find the latest playlist also. The last one of the batches, July 2024, weekend batch is over. And right now, weekday batch is going on. So the live sessions batch is going on. So I take weekday also, 3 days, weekdays, Tuesday, Wednesday, Thursday. 7:30 to 8:30 to 10 o'clock, 1.5 hours, 3 days. And then we have the weekend, 2 hour. I take Saturday, Sunday. So this is the weekends batch. So this is going to be our demo sessions. And similarly, when we complete day 1, day 2, day 3, you'll be getting recordings like this. Okay, you'll be getting recordings like this. These are the live sessions. So these go for 3 months, friends. The live session goes for 3 months. If you're starting the batch right now in October, it is going to be ending January only. So October to November, November to December, December to January. It's going to be end in the last week of January. That's how it's going to take, because it's a very vast thing. We talk about a lot of things here in this course. No, Ravi, we talk about AWS. As I told you, we cannot cover all the cloud. You need to be good at one cloud and you can easily learn other cloud. I can help you get started on other cloud because I always relate the services. So it doesn't make sense that we talk about all the cloud. We learn AWS and then you easily transition to Azure or GCP, whatever you need. So, but we focus on only one cloud. That's how we should learn things. Start with one, and then when you require, you learn others. That's how even I have learned. Started with one and then adopted. I have worked on 4 cloud as of now. It doesn't matter. If you know one, it's easy, simple. So this is the live sessions that we're talking about. Now we have the Linux part. The playlist which I'm going to share is this simple playlist of around 3.5 hours. My recorded sessions. I'll be sharing this on day 1, and you will be expected to complete this basics of Linux. Okay, and then for every topic that we have, we are going to share the PPT as well, like this. Like I was showing you the cloud part. This is the cloud PPT which I share. I share this entire thing here, the folder here. I add you to this. Let's say if I show you, there will be a lot of folks added here. I have been adding a lot of folks who have been taking my courses, joining my courses. Look at this. I give you the viewer access, and look at all the people, those who have been joined. And there are other folders also, but I have stopped creating many folders. I just keep it with this name and I just keep on adding. So I'll be adding you. Those who get enrolled, I'll be adding you here, and you get access to every files, folders, everything's here. So this is the cloud. This is the Linux part. Again, I have for the Linux, I have one more PPT, separate PPT. So this is for the Docker. This is for the Kubernetes. This is for the Linux. So that is going to be the Linux. And in the video also, I have been, again, earlier I should take this live session, but I've stopped it because I want to focus on, I want to cover most of the items, right? So that's the Linux part. So we cover about, you get comfortable here, start with the basics, and everything is hands-on. In the recorded session, I have triggered all these commands, and I have demonstrated each of these commands in the Linux. Everything is hands-on. Okay, I'm going to show you things doing. It's not the theoretical. No, it's a boring. Okay, only just talking about theory. You don't get anything, and when I don't get interest. So I would like to show you things that you are interested. You can see things. You can do things. If you have 2 monitors, one for the laptop and one monitor, you have additional. You can also do the hands-on with me right now. When the sessions are happening, you can manage your time if you have 1 monitor and 1 laptop. Yes, that's the Prashant. You'll be getting Linux machines, Prashant. No, need not worry. Okay, when I'm telling you, you will be practicing it. I'll make sure you have Linux machine. We are in the cloud, friends. I'll get you Linux. If you attend my day 1, you will be learning day 2. You'll be learning how to get a Linux server in the cloud without paying anything. And there will practice everything. You can practice whatever I'm going to show you things. You can practice the same thing. So don't worry about where I'll get the server. I'll guide you. Prashant, sound good? Okay. One of the questions I'm getting from Surendra, that Surendra is telling more opportunity coming in Azure. Why I selected AWS? Okay. So there are 2 reasons, Surendra. AWS was launched in 2007. Other cloud launched 5 years later. AWS still has the largest market share, 35% to 40%. Yes, Azure is the second most, 20%, going around 25%. But if you talk about overall, AWS still holds the largest market share. Okay, no doubt about this. Okay, now but nobody close. Yes, second, Azure is the second most. But as I told you, I have selected AWS because of the market demands. If you go and attend the interview and if you say that you have worked on AWS, they are not going to reject you because you know AWS and they're expecting Azure. No. First of all, I'll guide you in such a way that you will be able to answer things in Azure terms also. So it's very simple, okay? Since you're asking this question, let me show you. And I'm telling you, rest assured and rest assured, right? If you have a service called EC2 in AWS, which I'm showing you EC2, and I'm telling you that you have a similar service in Azure called virtual machine, both use case is same. In both, you're getting the server. The look and feel, the UI will be different. It doesn't matter whether you create server in Azure or in AWS or in GCP or in Oracle. You don't need to think about that. You need to think use cases. Why people use cloud? Think in those terms. They use cloud to get the server. They use cloud to get the storage. They use cloud to get the load balancer auto scaling group. So when you see things being done in AWS, if you're interested in Azure, you can create the similar account and practice. It doesn't take long. When you know one cloud, it becomes easy for you to transition to others. Okay. I hope I answered your question, right?
Yeah. Thank you so much, Raushan. Thank you.
Sure. Okay, coming back to the topic, why do we conclude AWS and start SRE? I could not understand, Arlene, your question. Prashant, do you have a question? You have raised your hand.
Yeah, just one question. In the between days of the course, if we have some doubts or something, so how do we?
You see, we will be creating a WhatsApp group, okay? A separate WhatsApp group.
Okay.
So let me show you live WhatsApp group that I have right now, okay? So every group, when you join, okay, like this, you will be adding in a WhatsApp group. And like this is the current batch going on right now as we speak, okay? This weekday batch, you'll be part of this and you can ask questions. Whenever we meet, I post message that please join and the video have been uploaded. So I'll be here in this every group. I'll be the group that we create, you'll be here. I'll be here, you'll be here. You can reach out to me over WhatsApp. So that doesn't matter. Easily. Okay. Every updates, you can post the question in the WhatsApp group, anything, it can be done. Okay. So
I just was meaning to ask you that how long do you think this we're going to take to complete AWS, and when do we start with the SRE part of?
Okay. So let me complete. Okay. So let me complete. I have just started with my course. Sure. Let me complete. Your question lies in all the details that I'm going to share. Okay, so that's the first part, friends. And the second part is Linux. So I've covered these two things. After Linux, we are going to talk about SRE concepts. Okay. We'll talk about what is reliability, what is fault tolerance, what is high availability, what is disaster recovery, what is SRE DevOps, what is SLIs, SLOs, SLAs, error budgets, incident management, change management, roles and responsibilities of an SRE. We'll talk about. So this is the course content. Now the flow would be different. After AWS, we talk about application architecture, because when I talk about SRE, right, you need to have some prerequisite knowledge. So I want to cover that first. Okay, so even if you look at the recorded session also, we have done the same way. Okay, the flow is this. So first we talk about cloud, and you will be getting this Linux recorded session. You will be expected to complete, and the cloud will take approximately 3 weekends. Okay, because we cover a lot of things. So approximately 3 weekends, 6 sessions will be going in the cloud. We'll be talking in detail about the cloud. So tomorrow we'll be starting with the cloud, day 1. That's how things will be. Now after the cloud, we'll be talking about software architectures. What is monolithic, microservices, We'll talk about how do we create containers using Docker. We'll talk about Docker. And again, various concepts of Docker. How do we create Docker image? How do we build application using Docker? How do we create containers and all those things? Then we talk about Kubernetes. Because Kubernetes is the most important topic in containerization, because that is the orchestration engine. You yourself would have experienced, I'm not sure if you're attending the interviews, how much they're asking the question in the Kubernetes. Friends, have we realized that we are being asked question in Kubernetes? Yes or no? Anybody would like to say yes or no?
Yes, definitely they ask whether do we have experience in Kubernetes.
Right, exactly. So that's where this course pitches in, right? Because I understand the transition when you are a performance tester engineer, or you are trying to be an SRE, or you're into production support, you don't have full-fledged idea. That is where this topics come. So we'll talk about Kubernetes in detail. What is containerization? I will demonstrate using EKS, Elastic Kubernetes Service. Is the AWS service? We'll talk about it. So again, how do we monitor Kubernetes? How do we load balancer? How the ingress works? How auto scaling works in Kubernetes? Same thing, I'm going to talk about auto scaling in VMs. When I talk about the cloud, I'll talk about auto scaling in VMs. In VM installation. When I talk about Kubernetes, I'll talk about how do we auto scaling in containers. Abhishek, you have a question? Do you want to ask right now, or you want to wait for some time? I prefer everybody, please wait for some time. You'll be getting all the answers. Let me complete. I'll take up your question at the end, friends. So we'll talk about Kubernetes. After that, that's the flow. Docker, Kubernetes. And then we talk about, friends, the DevOps part. As I told you, the 4 things that we are going to cover as part of the course. The same thing that we started in the beginning. Remember, the cloud. We'll start with the cloud. We'll talk about microservices. We'll talk about containers, Docker, Kubernetes, and then we'll talk about DevOps. That's the flow. Cloud, microservices, containers, DevOps. Because in DevOps, we are going to talk about how do we do automation using Jenkins. How, as you in the performance testing team, how can you help a DevOps team? So we'll talk about performance engineering in DevOps. What are different roles and responsibilities you have in a DevOps lifecycle? Yeah, I'm coming to monitoring part. Surendra, Abhishek, it's coming on the way. Just hold on for some time. So we'll talk about DevOps, friends. How can we do CI/CD pipeline? How do we do continuous performance testing in DevOps? How can we contribute as a performance testing team, as an automation team? How can we contribute? How can we create a Jenkins job? Because our job will be part of the pipeline. That is at the organization level. When the code is ready, things need to get deployed. Applications, the latest code has to get deployed in Nova environment. Then we need to do functional testing, performance testing, security testing, all these jobs, right? So we'll talk about this here in the DevOps part in detail. And everything is hands-on. I'm going to show you things. So when I say about I'm going to show you things, I'm talking about this. Let me show you the PPT, friends. First, let me just show you one of the diagrams. So I'll talk about the SRE part. I'll come here and I'm going to show you the pipeline that we create in the session, in the regular sessions. When I'm going to create this kind of pipeline, this kind of pipeline. CI/CD, continuous integration. So we'll create Jmeter job like this. And when the code is ready in the GitHub, when the developer has uploaded the code to the GitHub, how it can automatically schedule it, how it will trigger the pipeline automatically. We'll take care about that. So I'm talking about Jmeter here, Gokul. LoadRunner can be also integrated. Jenkins has a huge extension of LoadRunner as well, but I'm going to demonstrate here for the Jmeter. I can share a link for LoadRunner also. once you understand how the integration works, it's easy. Okay, doesn't matter. You can integrate Jmeter with Dynatrace, Datadog, AppDynamics. Jenkins. Sorry, you can integrate Jenkins with AppDynamics, Datadog, Dynatrace. Jenkins has a huge plugins. It can integrate with anything. So we're going to demonstrate using this CI/CD pipeline, right, as part of the course. Now, friends, we talk about SRE concepts. How do we see when you say about SRE, you need to understand one thing. We need to understand how do we achieve reliability. What is SRE? Site reliability engineering. We are responsible for designing the application which is highly reliable. What is reliability? If the application goes down, if some failures happen, failures will happen. How the application comes to normal automatically. Can the application recover automatically? That defines how reliable your application is, and how to achieve that is what we cover in this course. How do we achieve reliability? How do we gain reliability? How do we make sure the application is reliable, performing with cost optimization measures, high availability is what is the entire idea of this course. And that is what we focus. We talk about reliability here, friends, along with the reliability concepts. So we talk about the concepts later, much later, when we have discussed about cloud, when you discussed about Docker, Kubernetes, Jenkins, when you understand automation, that is when we talk about reliability concepts. And that is what you make sense, because when I use the word managed services, we use managed service in cloud. You should be able to relate what is a managed service in cloud. How can you make your application reliable? How can you cut down your error budgets? How can you make sure you can manage your incidents? So when I talk about in those terms, you should be very much up to speed with me. That is why we covered everything prerequisites first. As prerequisite, you can talk about SRE. Everything one and same. It's all about knowing what is what. How do we handle disaster recovery? How do we achieve high availability? How do you make sure the application is reliable? Is what we're going to talk about. How do we measure SLOs? What is SLIs? So we talk about these things, right? And friends, after that, we'll continue to discuss about automation things. How do we gain resiliency? Then we talk about observability. As part of observability, friends, I saw a couple of questions, Surendra, Abhishek. Friends, we cover these things as part of observability. We cover how do we monitor things in Linux using commands like top, star, mpstat, vmstat, iostat. We talk about Linux monitoring. How do you do shell scripting? We talk about that. We talk about CloudWatch as part of AWS monitoring solution. We demonstrate using CloudWatch. How do you measure things? How do you capture metrics details in CloudWatch? We talk about that. And we take up 2 open source tools. We don't take any commercial tools in this course, just for obvious reasons. Yes, I'm covering how to dashboard creation. Yes, Surendra. Yes, Prometheus and Grafana and Elk. These 2 monitoring tools we cover as part of the course, along with dashboard creation, alerts creation, everything. Okay. We don't cover. No, you can answer. You can ask why have we not covered Datadog, Dynatrace? And this is the course. If we keep on putting, this will go for 1 year. Okay, I can make this course to go for 1 year also, but we have to understand the requirement. Open source, why we have taken it up, because that's the highest in demand. Every other company, they want to use open source, and you have CloudWatch also as part of AWS services. So we have selected these 2 things as of now. We're not covering any commercial tools like Datadog, AppDynamics, Dynatrace, New Relic. No, we are covering these things, but we are covering in detail, right? That is the important thing. As part of observability. Now, as part of troubleshooting, what we do. So friends, again, since we have a lot of things to cover, and this live is, I saw somebody raise the hand. Surendra, you still have a question, or you
Yeah.
are?
Yeah, I'm just looking for the certification part, Rohan. So it will be great if you can cover after completion of this course, what gonna
Yeah.
eligible
See,
for attempt.
you can go with friends SRE practitioner certification. If you know about the certification, you can apply for this. You need to yourself get the exam schedule, but you can very much. We cover SRE, all the concepts as part of this certification. I hope you know about the certification, right? That we have from DevOps Institute, SRE practitioner. You can go over the certification and you can easily complete it. It hardly takes some time because we cover in detail, and everything that you see in this certification will be covered as part of the course, and you can buy the certification, pay for the exam, get certified. Sounds good?
Yeah, awesome. Thank you.
Now, coming back to the syllabus, friends, I'm going to share the link with you. So I've shared 3 links with you. I'm going to consolidate those 3 links also. Okay, let me consolidate this for you, friends. I have shared this link with you, and I have shared these 2 links with you. I'm going to send you anyway again, but let me put it handy. Okay, I'm going to share it again anyway. So now coming back to the course, friends, for troubleshooting, I'm going to share a recorded session. Again, my recorded session, Java Performance Engineering. Ravi, you have a question?
I just wanted to check quickly. I mean, when you say alert and monitoring using Prometheus and Grafana, do you cover the monitoring part only, or this course covers the implementing of alert and monitoring as well?
Correct. See, I show you how do you create alerts.
Okay, so it's implementing the alerts as well from the code and from the file beat and the logs, yeah?
Correct. So once we have the dashboard, once we have the metrics, when you see the metric, let's say CPU, memory, how do you create alerts, right? And what should be the right threshold? We talk about those things.
Okay, thank you.
Sure. So on the troubleshooting, because see, when you say about SRE, friends, or cloud performance engineering and DevOps, we need to be good at Java is still the most popular language, and we cover, I give you this recorded session as a Java performance engineering. So this is going to be the recorded session. Let me again show you. This is going to be again my recorded session. I have recorded it earlier. I used to take this 12 hours, but again, if I again merge it in the regular session, our course will go for 6 months. Okay, so that is the only reason why I was doing it earlier. Then we trimmed down by giving you some recorded session and live sessions. We found a balance, and this will be given as part of the course, which talks about Java performance engineering. We talks about JVM architecture, how JVM works, how Java programs get executed, how memory plays an important role, different GC algorithm, how we take a heap dump, analyze the heap dump, how do we take a thread dump, how do we analyze thread dump, what is GC log, how do we analyze GC logs, everything about the Java performance engineering will be covered as part of this recorded session. So will be giving this as well as a recorded session. So there are 2 recorded sessions as of now, as we have spoken. One is this guy, Java performance engineering, and other one is Linux. That's all, right? On the recorded sessions, along with this course, we are also going to give you the core Java and the Python scripting. Okay. Again, these are not my recorded sessions, Python programming and Java programming. Okay. These are not my recorded sessions. Again, I'm going to tell you, but they are from the Isha trainers, good trainers. I have reviewed them. It's good for you to get up to speed on Java and Python. Java will be given to those who will be opting for only the cloud performance engineering and DevOps, and Python will be given to the SRE people. Python is much more 30 hours in detail. So that's the only difference about the course. The cloud performance engineering and DevOps and SRE course. That's the only difference. Yes, Ravi, Narayan, I see you both have raised the hand.
Narayan here. Actually, about Python and Java, do we require and where we are going to use this programming language in SRE?
Okay. See, as an SRE, you need to understand the roles and responsibility. As an SRE, your roles and responsibility is to maintaining the production reliable, not non-production environment. Right now, Narayan, you are performance tester or engineer, if I'm not wrong, correct?
Correct.
Okay. So you are not working in production systems, correct?
Right.
As an SRE, that's the basic difference between a normal performance engineer working in non-production environment and production environment. As an SRE, you are responsible for maintaining the production reliability. When you access flipkart.com, there's a production systems, you hit flip production systems, things may go wrong there. We cannot cover all the use cases that happens in production in non-production environments. So that's one of the responsibility of a SRE. That's why your performance engineering domain along with whatever we are covering will help you. The infrastructure part, the cloud part, the Kubernetes part. Along with that, as an SRE, we are responsible for automating stuff also. A lot of stuff, mundane stuffs. So Python is very important for the automation part. So we don't need to code like a developer in Python, but we should learn Python from the scripting perspective. How do we automate stuff? That is one of the roles and responsibility of a SRE engineer. Additional responsibility of an SRE engineer, because you are in production and anything to do with production reliability, anything manual activity that let's say you're doing, you need to do a backup of files, backup of databases. How will you do that? Will you do it, keep on doing manually every day? No. I just give you one of the examples. Let's say you need to create a data, you need to dump a data, you need to give it to some customers. Will you be doing it manually every day? No. You will find some automation way. And that is when the Python scripting will help you. I hope you understood.
Yes, Roshan. Yeah,
Good.
I got it. I got your point.
Sure. Prithvi, you have raised your hand.
Yes, sir. So I'm just confused. Like, what is the then the role of a DevOps and the cloud performance engineer? Like,
You
if
are
I take
asking.
the course for if I take the course for the cloud performance engineer or the DevOps, like then what is the role for the SRE, sir? Like, what is the difference these three are?
Okay. See, as a cloud performance engineer, you work in non-production environment. Non-production environment, correct, Prithvi? You are not responsible working in production systems. So it's all about the responsibility that you want to pursue. As a cloud performance engineer, you need to know about. So do you agree, Prithvi, that as a cloud performance engineer, do you need to know all these four things? Prithvi?
Yes, sir. Yeah.
It is covered in the course. So that is how this course is going to help you if you're looking for a cloud performance engineer. See, it all depends. Will this course help a cloud performance engineer? Yes. This course is going to help SRE? Yes. DevOps, we are not covering a lot of things in DevOps in detail. DevOps is full about deploying the code to various environment. If you look at the role and responsibility of a DevOps engineer is the deployment, code deployment. You are not going to be deploying the code day in, day out. You are here to troubleshoot things as a performance engineer or as a SRE engineer. You are going to talk about the reliability of the application. DevOps engineer deploys code. That is what DevOps engineer does. To various environment, lower environment, QA environment, dev environment, release environment, performance environment, production environment, they deploy the code. And then they are not worried about production reliability. See, now there could be a bigger team, which we're calling a DevOps SRE team. There could be a case. Few people are into the various shifts. They're into role of L1, L2, L3 of SRE. The same team would be doing deployment. So you need to choose what is your aspirations going to be, and that this course is going to help you. Prithvi,
Yeah.
I hope.
Yeah. Thank you, sir. I got cleared now. I was confused between these three. I got clear. Thank you.
Okay, cool. Okay, friends. So that is what we are going to cover, friends. And then we are going to talk about automation using Ansible and Terraform. Okay, which is important from SRE perspective. So we are going to talk about. So this is very much specific to SRE. Okay, using automation part. So automation using Terraform, automation using Ansible, right? So we are going to talk about these two things. So this is what this course offers, friend. Okay. So I am done with my part, whatever I wanted to cover.
So
You
any
have any?
project will cover, sir, for this one projects?
See, every day will be a project, every day will be assignment. So it's not like a project you do this. Every day will be doing stuff. Every day. Daily basis will be doing a hands-on and daily basis will be doing a project thing. So this course
Okay,
is
sir.
designed in such a way. Yeah. Yes, Subham, you have a question?
Yeah, Roshan. So I just wanted to ask, over the duration of this course, will also we get the knowledge how do we deploy code on different microservices servers and
Yes.
yeah.
We get the idea. We get the hands on. See, when we talk about deploying microservice on the containers, I'm going to demonstrate you, right? I'm going to demo how can I complete this without deploying the microservices on the containers. When I talk about Docker, Docker is meant to create containers and deploy applications. And I'm going to show you how do we deploy microservices. When I talk about Kubernetes, I'm going to show you how do we deploy microservices, the pods on the pods here, right? And how do we auto scale? Definitely, we are going to talk about those things. Yes.
Okay. Thank you.
It's a weekday course or weekend course?
Weekend. Okay. This course is the weekend course. Weekend batch is coming. Timing is mentioned here in the first part. Today is our demo session. We are on 19th October. From tomorrow, day one, friends. The course is starting from today. So tomorrow is the day one. We'll continue tomorrow and then the next weekend and we'll continue. That's how the things will be.
Okay. Or you will give some exercise to daily?
Daily. Daily, you are expected to do things.
Okay. Sorry, but
That is how I'll try. So that is how you will learn. When I talk about AWS, you will be comfortable in AWS. That's my responsibility. You need to follow my things. Whatever I'm going to show you, you need to repeat this exact same stuff and do more stuff. I'm going to tell you what to do. If you follow my things, whatever you see in the course, you will be able to complete in 4 months. 3 months, I'll be doing that. And 1 month, you need additional. You'll be able to complete everything in 4 months, whatever it's mentioned in the course. Okay. This is a vast course. Okay. It needs some time. So.
Okay, sure. But market, I didn't about this position. They asked to performance engineering only. They asked, but especially
you'll be shocked to know. Okay, there are more positions for SRE. I'm not sure where are you checking. Okay, if I show you the jobs of SRE, you will be more than the performance engineers.
Okay.
I think you're not looking into the right places. Go to LinkedIn and right now just Google it. Okay. You will be amazed to see. You'll be amazed to see the openings in SRE. Okay. I cannot keep on scrolling the pages. It will not ever end.
No. Thanks.
For my understanding, if we enroll for one course, this may sir you cover both cloud performance and site reliability engineering, right?
Correct. That's absolutely right, Peter.
Okay, thank you.
Yeah, Roshan, Narayan again. Can we have some sample profiles, how to prepare SRE resumes
Yes,
based
I'm
on
going to share.
AWS or
Yeah.
GCP or Azure.
Yes, I'm going to. I do share at the end. I do share that.
Okay, okay,
I help you writing few lines, what all you should add in the certification as part of resume. I'm going to share at the end. So without knowing writing will not help. So first I will make you understand things, then you yourself will be comfortable in writing it. Because I have been in
okay,
those shoes. I have been performance engineer. I have been SRE. I have been principal SRE for many years, so I know the expectations. So yes, I'll help you there.
okay. Got it. Thank you.
Roshan, one question.
Go
So
ahead.
the content of the course, we will be getting one by one as the class progress, or like we will getting the content at once and then slowly
No,
covering up the
no.
course.
As I told you, right, you will be getting this kind of a playlist.
Yes.
And this is the live playlist I'm showing you, right? I can also
Mhm.
show you the current batch, last batch, which is going right now. So in the those batch, you will be only seeing, will be only this will be updated on the regular basis. Like this. Let me show you again. If I
So
show
this
you,
we get the whole playlist, right?
you get for the live sessions, you get the link as we cover. Video has been uploaded. This is the current batch going on. And when the batch gets completed, the course gets completed, we upload the video on live. That's about the live sessions. The recorded sessions, whatever you saw, you'll be getting it anyway.
Okay. Okay. So the playlist that you were showing, we will be getting the details, like all the content at once. And
The recorded session, the
okay,
Linux, the Java performance engineering, the
got
the Java programming, and Python, if you're enrolling according as per the SRE or right. So
and
the
these
you'll be
these content we will get as the class progress, right?
correct. This you will get as the class progresses. Absolutely right. Because these are the live sessions. These are not. If you want, I can share the old recording. I don't want you to get demotivated. I don't just dump you everything. I can, if you want. No, I want Roshan. I can give you the old batch.
Got it.
I have everything. I have been since 3 years. I have been taking batches. I can give you any course, any batch, right? So that does not help you, right? This is the current batch, okay? This August batch. So I have shared, this is a weekday batch. I have shared only this 20 recordings. This is the weekday batch. So I've shared only these recordings. So yesterday I've taken AWS EKS Kubernetes. So
So
I
we
have
have batches only on weekends, right? Not on weekdays.
correct. So the one that I'm talking about is only for the weekends. So don't get confused. I see many people are getting confused. Why confusion? This is how weekends. We are gonna this batch for the weekend. There is no weekday batch is coming right now. Weekday batch will come after 2 months because the batch has just started 1 month back. So right now we are gonna with coming up with the weekend batch. 19th is the weekend, 20th is the weekend, 26th is the weekend, 27th is the weekend. This is the weekend batch we're talking about.
Understood.
Okay. Any other question?
But you told it's 2 hour session, but here mentioned 1 hour session only.
Okay, leave about it. So the person from Isha has done it. Don't worry about it.
Okay.
Usually it's 2. Look at this. So maybe she has done it till day 2, 1 hour, but look at this. All are 2 hours only. Maybe she thought it's a demo session. It'll complete in 1 hour, but we are going in detail. Don't worry about it. It's 2 hours.
Raushan, for confirmation, if we want to enroll, so we enroll to mention to admin that we need to enroll as site reliability engineering or cloud performance.
In DevOps, yes, you can enroll in either of the courses. The content is same, only one part is different. The Python. and Java.
Code Java,
right?
okay.
And Java,
Or,
and then there are few automation things is different. You see, it will not help you, but if you, so we are covering Terraform and Ansible as well as part of SRE.
So from your advice, is it appropriate that we sign on for site reliability?
Exactly.
engineering?
I would,
Okay.
if I would be in your shoes, I would, if I would be in your shoes, I'd enroll for SRE, because SRE demand is going up, and there are a lot more many openings right now as compared to performance engineer. So it is like for performance engineer, it's like adding some additional skills and be into SRE shoes. That's how I see it. So there are some additional skills like automation is required, right? Some DevOps knowledge is required to be in SRE. See, as a performance engineer, you should be good at troubleshooting. You should be good at understanding architecture, and those two are very much required for SRE as well. For SRE, what we need is the automation, which performance engineers lack, or they do not have the right skill. So, and that is what SRE, we are talking about the automation here. How do we automate stuff using Terraform, Ansible, right? Shell scripting, Python scripting. That's what we talk about additionally. So I don't have doubt if, because SRE is having more topics in this as part of this course.
Yeah, one more question. This means under this SRE, you will also cover cloud technology.
Come again? What will I cover?
Mean under this site SRE, you also cover the cloud like the AWS.
Absolutely, those are common things, right? I don't get confused.
Yeah.
Everything is common except few things.
Okay.
Whatever I talked is common for both, except for few things, except for Python. Python is not there in cloud performance engineering, and your automation is not there in cloud performance engineering. That's it. Everything is same.
Okay, thank you.
Don't get confused. Don't get confused at all.
Thank you.
Cool. Any other questions?
I think we are good, Raushan.
Perfect. Thank you so much, everybody. We'll meet tomorrow and we'll start with our day one. Thank you so much.
Thank you so much.
Yeah, thank you, Raushan.
Thank you.